All right, this example is very similar to the previous one, except that we're looking at the limit as x goes to 0 of just 1 over x. All right, so again, we can just sneak up on 0, right? Because we know we can't put 0 in, we can't take 1 over 0. So the value of 1 over x at 0 doesn't, it's undefined. So but again, we'll sneak up on it. So let's put in some values. So this is a negative 1/10. The reciprocal of that is a negative 10. Negative 1/100th, right? 1/100th. So the reciprocal is a negative 100. Negative. All right. And then this is 1/1000th, negative 1/1000. So when we take the reciprocal of that, we get a negative 1000. All right. Okay, so now you notice that we put in a negative. We get a negative, right? Because it's just 1 over x. We're not squaring it. So if we put in smaller and smaller negative numbers, right? So closer and closer to 0 from the left, right? It looks like those numbers are going to get larger and larger in magnitude, but they're going to be negative, all right? So the magnitude is going to be large, but negative. Okay, so we can say that the limit as x approaches infinity, the limit as x approaches 0 from the left of 1 over x is a negative infinity. Okay. All right, now we can do the same thing. You can approach 0 from the right. Okay, so we're going to get 10, we're going to get 100, and then we're going to get 1,000. They're going to be positive this time, and I can put in smaller and smaller numbers, and that 1 over x is just going to get larger and larger and larger, but this time it's going to be positive. So we can say that the limit as x approaches 0 from the right is a positive infinity. Okay. Now, they don't match, right? So the only thing we can do here, the limit as x approaches 0 of 1 over x is just does not exist, right? Now, again, like I said, these limits don't exist, right? They're not finite limits, but or they're just becoming arbitrarily large, either in the positive or negative direction. So, and when we have that happen, right, we get what we call a vertical asymptote. So if we were to graph 1 over x, we would get something that looks like, let's see, where should I put it? I'll just put it here. If we graph 1 over x, you've probably seen the graph of 1 over x before. It looks something like this, right? It looks something like this. This is the graph of 1 over f. F of x equals 1 over x. And we have this, the value at the vertical axis is where x equals 0, right? And so we have an asymptote at x equals 0. We have a vertical asymptote. I'm going to just abbreviate it VA at x equals 0. Okay, now x equals 0 is the equation for a line, a vertical line, right? Because everywhere along that line x equals 0, x is 0, right? So it's a vertical line. Okay, so we say that a line x equals a is a vertical asymptote if f of x if either the limit either approaches plus or minus infinity as we approach from the left or the right. All right, I'll meet you in the next video.